I've got 5 bad C++ habits that you are probably still doing. And they are not the boring things most people talk about. And let's play a game. I have a question for each bad habit that if you get right, you get a point. To measure how good your coding habits are, and you can write your score in the comments at the end of the video. I'm low-level game dev, and I've been doing C++ game dev for 10 years. In that time, I've seen time and time again the same mistakes people do. Starting with number 1, not initializing variables. Some time ago, I was talking with someone that had a code like this, and I told him to initialize his variables inside this struct. His response was that he initializes the variables later, so no need to also initialize them in the constructor. At first glance, this might seem harmless, but in reality, it's a super bad practice. As the project grows, and you use this struct in more and more places, and you start to add more and more structs, the chances you forget to initialize all of them everywhere grow exponentially. Like, this is a 10,000 lines of code project. Can you tell me if this is initialized correctly everywhere in the code? What about now? So, if you always make sure to initialize every variable, you get a point out of 5. And besides, that's the point of the constructor. You should initialize your things here, not outside the struct, so people can easily know how this struct is supposed to work. So always initialize all your variables. In this way, everything will be in a somewhat valid state. And you can also use this trick to reset structs to their default states. Also, try to keep the default values to 0 if possible. And finally, please stop initializing your members inside the constructor. It's 2026, we have C++ 11 for 15 years, and this is horrible to read. I have no idea why people write code like this. And if you are one of them, I have just proven that it's bad. Because this code actually has a big bug, and I bet you didn't even see it. This member is never initialized, but you can see that if you write the code like this. But if you do it like this, you see the problem immediately, and you can also very easily see what variable is initialized with what. But speaking about variables, and I can't believe I have to talk about this, but the second bad habit is declaring all the variables in the same place. If this code makes you vomit, you get a point for this habit, but if you write code like this, you get no point. Short history lesson, but a long time ago, the compiler was super simple and couldn't handle declaring new variables in the middle of the function. So in like the first version of the C language, you had to declare all variables in the top of the function. This bullshit practice was passed from generation to generation, and somehow, 30 years later, some teachers still do this. If you don't understand why this is horrible, let me take some random code from my Minecraft game made in C++ and move all the variables in the top of the function. Yikes! Make the habit of declaring the variables when you want to use them. You want to use this variable inside the for loop only, so move it inside the for loop. In big functions, I sometimes even create blank scopes to isolate variables from the rest of the code. Next we get to bad habit 3, and that is allocating things on the heap that should not be on the heap. Whenever I look at the code of a beginner, I see pointers everywhere, and I know immediately something is wrong, because if you look at my code, you see pointers quite rarely. Just to be clear, there is nothing wrong with using pointers, but after I explain this bad habit and the next one, you will understand that you don't need them as often as you think. So a ton of people, when they make an instance of a class in C++, they just create it on the heap, probably because that's how other languages work. If you think this code here is okay, you get 0 points for this habit, and you get 1 point if you'd rather write the code like this. And the reason is that you gain absolutely 0 benefits for allocating this on the heap, but you get drawbacks. As your code grows, if too many things are randomly on the heap, and everything is an ownership question, your code will simply fall apart. You should only allocate things on the heap if you have a reason for that. For example, if you want to make a tree-like data structure, you might allocate stuff on the heap, or if the object is big, or if you want to use a vector. I use vectors and other things like that quite often. And by big, I mean not like a few members inside. I mean like actually super big. And I have heard all sorts of excuses and imaginary problems. Like some people worried they would run out of stack size. That won't happen. And if you don't believe me, I made a 3D game entirely on the stack, so you can check that out. Memory management in C++ is easy if you keep it simple, and I made a video about this. But as a simple example, this is the asset manager for my games. I just hold all the textures and other assets here. As I want to use them, I don't take them as pointers. And I absolutely not take them as counting references. I just use them directly from the asset manager, whenever I want to use them, and that's it. So if you look at my multiplayer Minecraft game, you will only see me use the word new like 10 times in the entire codebase. So don't just randomly place classes on the heap for no reason. But getting into mistake number 4, I have more examples for you. And mistake number 4 is writing your code in a way that encourages problems. You probably already know that when you have a big task to solve, you have to split it into smaller systems. But if you want your code to not break apart as it grows, you have to design these systems so that it's hard for you to use them wrong. Let's say you want to implement a read from file function. You just read all the data from the file and return the result. And many people would here allocate the data and return it. But this means it's easy for the user to forget to delete the data. So I would instead just return a string or a vector of unsigned int. In this way, it's easy for the user to do whatever he wants with the data, and it will be automatically deleted. Now it's your turn. What is the problem with this function? I see this all the time. It might seem harmless. You just initialize some things for the class. But because we ask for a pointer, the user could potentially pass a null pointer there by mistake. If you identify the null pointer problem, you get 1 point. The level 1 thing to do here is to check if the data is not null. And you should do that absolutely every time you have a pointer that can be null. But there is a better option. You can guarantee that the pointer is not null by asking for a reference instead. In this way, you know for sure the data is not null. And also, the user knows that he can pass null data to the function. As a convention, whenever I use pointers, that means that the pointer could be null, so it is optional. And whenever I use references, it's clear that the data is not allowed to be null. See how I'm making it hard for things to fail? And there are more examples. This function reads the data from an array, but I always check that the input is correct. This function initializes a system, but if I pass some values that are too big, the system would break, so I check for that. And whenever I load settings for my games, I then call this method. It makes sure all the loaded values are within the allowed ranges. So basically, the setting system can never fail. You can literally try as hard as you want to break this load function or modify the save file to give it the wrong data. But no matter what happens, at the end of the function, the settings will still have values within the normal ranges. But let's finally talk about mistake 5, because it will determine if you evolve in your C++ journey or you just remain stuck at the same level. The only way to evolve in your C++ journey is to make big projects. And I mean a big project. Whenever I talk to beginners, they ask me what book they should read or what features they should learn about. But that's not the right way to go about things. Why do you think watching talks about clean code and design patterns feels good and easy? Because you don't evolve in any way. You have to make a big project, and it has to be hard for you. And it feels hard, because your brain is training and evolving your coding skills. Just to be clear, I'm not saying that you should not learn new things. You have to learn new things, but you will learn them as you make big projects. Like, while making a game, you might want to implement physics and collisions, so you will research how physics works in games, and then actually write that yourself in the game. So the fifth mistake is not spending time actually coding big projects. What does a big project mean? It is based on your current level. So if you just made your first Snake game in the console in 200 lines of code, your next big project should be a little bigger and harder, like Tetris in 500 lines of code. So if you often push yourself with hard projects, congrats, you got the last point. But if you have recently procrastinating by reading some theory and not writing code, then you don't get the point. And here is what you can do. I know it might seem scary to start a big project, but it's actually not that hard. All you have to do is keep things simple and take things step by step. For example, you can learn how to make this Tetris game by watching this video by JVDX9. Then, using that knowledge, you can make a simple RPG game in the console like this. Don't overthink things, don't plan ahead too much, and absolutely, don't try to write too many systems at the same time. You need to display a map for the game. So you can start with that. Just store the map as a string and display it. Then you need a player. So you need a position and a way to move it. Next you may need a camera. So implement that. And so on. And this applies to any level that you are. Now, if you are interested in game development and you'd like to make your first big C++ game, I just released a course where I teach you exactly that. I show you step by step how to code the game in 6.5 hours of video content, just like this one, step by step. And I also have 50 plus challenges for you to implement on your own, and many bonuses, so you can really evolve. Check the link in the description, and it might have a special discount. See you there.